speaker is Dr. Liza Abraham. She will focus on examples of experiments that she's developed based on green chemistry principles that match learning outcomes of standard reactions. She will demonstrate the undergraduate research projects focusing on green chemistry that can be undertaken with minimal infrastructure and reduced cost. Take it away, Doctor.
Thank you so much for for inviting me. It is really my pleasure. So I'm just going to show you some of my attempts in developing some undergraduate chemistry labs. So I'm an associate professor at Ambrose University, Calgary, Canada. Before I start my presentation, sorry, I think I'm not on presentation mode. 1 second. Yeah, okay. So before I start my presentation, I just want to tell you that I was into green living. So I was a soap, I used to make soap. I used to make lip balm, body butter, face cream, and conditioning shampoo bar, all 100% natural. So I was into green living from 2012. So maybe I just feel like that maybe green living was my passion. That might have maybe the driving force for me to enter into green chemistry. So when I joined Ambrose, so Ambrose University is a private Christian liberal arts university, and we only have a BSc in biology. There is no chemistry major, and I'm the only one chemistry faculty here. And but Ambrose is the first in Alberta and third in Canada to join the green chemistry commitment, which Amy was mentioning in 2020. Our main initiatives are in these areas. We have the green chemistry curriculum. We are trying to infuse green chemistry principles from starting with the general chemistry course, and we take the students through green chemistry into all those 4 years. We do develop greener organic chemistry and general chemistry experiments. And we have a successful undergraduate research program in green chemistry. These are for students who are doing a minor in green chemistry. Also, we have a high school outreach focusing on green chemistry. And we did 2 times international connections in 2017 and 2019, the topic was on sustainability. We do offer a minor in green chemistry. This is just going to start this coming fall, along with the normal chemistry minor. So I will just start with the organic chemistry experiments. So we developed a series of experiments, actually 5 experiments based on cinnamon. And the first experiment was distilling cinnamon oil from the cinnamon sticks. It just happened that the NMR showed that it's basically pure cinnamaldehyde. So we decided to carry out all the experiments based on cinnamon oil itself. So we haven't used any, pure cinnamaldehyde. We used the cinnamon oil because the NMR was the same. So this shows that it's cinnamon oil is a safer and renewable resource to carry out nucleophilic addition reactions. We know that nucleophilic addition reactions or carbonyl chemistry is a major part of organic chemistry curriculum. We have nucleophilic addition reactions there and also the enolate chemistry. So cinnamaldehyde can be a good substrate to carry out a variety of reactions there. And it has the favorable structure with this aldehyde group. And the cinnamon oil, we haven't done any further purification. We just use the cinnamon oil as our starting material for all further experiments. So these were the experiments we have done. So we got the cinnamon oil or the cinnamaldehyde from the cinnamon stick. Then we did a Schiff-based reaction, a reduction reaction, and an aldol condensation reaction, and finally an antimicrobial activity lab. So we have used different green chemistry principles in all these reactions. For the reduction reaction, we have used the microscale column chromatography, and Schiff-based reaction was conducted in water. And the aldol condensation reaction, we have used this to demonstrate carbon-carbon bond forming reactions and also sunscreen chemistry. And this, we know that this constitutes a real life chemistry practice. And we also provided the students with some research experience. They compared the UV spectrum obtained for the compound with the other sunscreen compounds, and they did some research activities here. And the last lab, we, along with the green chemistry aspect, we tried to give the students some interdisciplinary experience because, as I mentioned earlier, our students are all biology students, so they will be happy to see some drug discovery or antimicrobial activities. So we have used the cinnamon oil, cinnamaldehyde, ship-based, the reduction product, and also the aldol product, and they have done an antimicrobial activity. So with the positive strain and negative strain E. coli and Staphylococcus, and they got a wonderful result except the aldol compound. So that was our final experiment in that series. So you could see that actually almost 9 of the green chemistry principles were applied in all these reactions. So moreover, it actually reduced the cost and storage of chemicals through these micro scale practices. All of these reactions were done under micro scale practices. Maximum was 200 milligram scale. And all of them demonstrated the principle of atom economy. And again, as I mentioned, they demonstrated at least 9 of the 12 green chemistry principles. So through these green chemistry experiments, it's our commitment to give them experience in normal laboratory techniques like distillation. Actually, they got experience with the distillation, recrystallization, melting point determination, liquid-liquid extraction, filtration, TLC, column chromatography, UV, FTIR, and NMR spectroscopy. And along with they could safely and effectively perform synthetic organic reactions. The next experiment was actually a green nucleophilic aromatic substitution reaction. We simply used a green white t-shirt. And this here, we know a typical nucleophilic aromatic substitution involves strong nucleophile and nitroaryl halide and typical solvents like a DMF. But we have replaced this with a tie-dyeing reaction. So we have a procyon dye here, and also the nucleophile was generated from that cotton t-shirt. So this is the cellulosate nucleophile that attacked the procyon dye, and the color part that become part of the t-shirt. So these reactions have some more advantages because we could see that the toxicological properties of the dye will change after the dyeing process, so that the product is actually reusable and biodegradable. And throughout the reaction, we know that water is the only reaction medium, no organic solvent. And we just use sodium carbonate to generate the nucleophile. And dyes contain no heavy metals or any other toxic substance. And the end product is reusable and environmentally friendly. So we can actually teach the students about designing for degradation. So basically this cover almost everything except one green chemistry principle, and actually 2. There's no catalyst involved here. We also used this experiment to teach students about environmental stewardship, because in this reaction, not all the dye material will get attached to the t-shirt. 20% will go as waste. There's a side reaction occurring there. So what we did is we had a pre-lab experiment for them to ask them to explore the environmental and health issues related to procyon dyes, and to find about the possible solutions, how we can remove it. So students already done this as their pre-lab work. So once we finished the dyeing experiment, that only took 45 minutes. It's a 3-hour lab. So the rest of the time, what they did is they started trying this to remove the dye molecule. And this is actually the results from their experiment. So that in that way, we were able to teach them to be responsible citizens, not just throwing out, the waste material, but actually taking care of them in a sensible way. So the other experiment we designed was citronellal, another naturally occurring aldehyde. So this one our goal was actually to introduce guided inquiry approach. So we wanted the students to conduct some literature search and having some brainstorming. So they read some papers and they will collect all the literature concerning the synthesis of isopolygol from citronellal. They would have a table listing all the reagents, everything, and they will work together in groups and having a lot of discussions. And they would also have a table with the greener methods. And their assignment was how to make it more green. So there was a lot of discussions involved actually. And finally, lead them to design an experimental procedure and to carry out the experiment, eventually analyze their results and communicate the results through a scientific poster. So it actually took 2 lab periods, that is 6 hours of lab period. So students were divided into groups. One group may try the various reaction time, other group may try the different types of catalyst. And finally, the best results were the reaction was completed in 2 hours. The reaction conditions were very mild, simply mixing them together, stirring at room temperature with the MG10, that is monomerlate clay, in phosphate buffer. Again, lots of green chemistry principles were followed here. And the guided inquiry have lots of benefits. It's a student-centered learning, and it can increase students' critical thinking, cognitive reasoning, and problem-solving abilities. And it involves some research process. It's not just following some written procedure, but they are actually designing their own procedure. And also we noticed that using this, taking that time, that 2-hour lab period, and going through this guided inquiry process, the students actually appreciated the green chemistry principle more, and they have the pride ownership of designing their own experiments. And I just want to show one example of undergraduate research we are doing here at Ambrose. This one was, we used chitosan. So we know that chitosan comes from chitin, just a partial hydrolysis of chitin gives chitosan. Chitosan has amino group, and we have used these 2 aldehydes, cinnamaldehyde and citronellal, both, and to react with this amino group to form ship bases. So the student prepared 2 ship bases, each one from cinnamaldehyde and citronellal, and then evaluated its antimicrobial activity. And we did some studies and FTIR to characterize the material, eventually to do the antimicrobial activity for E. coli. And these are very good materials that can be used for wound care, in wound care products, or so many other applications. So that was just one of the projects we have done here. And that is very important for us, because we all know that, actually National Science Foundation and National Research Council both promoted research-based learning as the gold standard in undergraduate science education. And the Boyer Commission, the Higher Education Academy, the Association of American Colleges and Universities all share a conviction that undergraduate research improves quality of learning by stimulating students' curiosity and encouraging them to think independently. They all recommended that all undergraduate students should experience learning through research and inquiry. And also it not only affects students, but faculty, like for promotion and things like that. We also need to publish papers, everything. But at the same time, in a university like mine, it's very small. There is no chemistry major. And even for my first promotion, I need to publish 3 peer-reviewed publications. So we only have a teaching lab. We don't have a research lab. We just have very few basic equipment. So it can remain as an underutilized pedagogical tool. Research is costly and time consuming, and also we have limited physical financial resources. In that case, it really helped us to use green chemistry. It offers a promising way forward for universities like ours, and it has the benefit of all the other benefits of undergraduate research, but it can be taken with the minimal infrastructure and reduced cost. We have more benefits. We can help to reinforce the values of safety and sustainability for future chemists. The project I just showed you, we know that it has scientific benefit. It also has pedagogical merit, showing how green chemistry can enable institutions to offer valuable undergraduate research opportunities with the limited funding and infrastructure. I forgot to mention that in my slide, all the students who worked with me, we published the papers together. So that helped them to get into the mid school or graduate studies. So the another project we have is high school outreach. This is mainly focusing on the green chemistry. So we have reached out 11 high schoolers in and around Calgary. And this is the latest one. This work happened in this May. This was a spring high school outreach. And the last project we are doing is Internationalization at Home. This is funded by Ministry of Alberta. 2017 and 2019. My environmental toxicology class was connected to 2 other universities in India. And so the students studied alongside for 4 months on topics on environmental sustainability. So our main, we wanted to teach them three important core skill sets. So those were intercultural competence, global citizenship, and environmental sustainability. So we chose the topics in such a way on focusing on sustainability. So students had a wonderful experience. Students experienced significant changes in their attitudes and values and when they began to see environmental issues from a global perspective. So this manuscript is under preparation. So we did student feedback, and students even picked up some local dialect and food habits, and it was a wonderful experience for the students. Unfortunately, we will not be able to continue this because there's no more funding for that, but it was such a good experience connecting globally with the environmental sustainability topics. And I want to give thanks to Beyond Benign. It's such a huge encouragement, the Green Chemistry Commitment Program, personally to me, Ministry of Alberta for funding the international projects, and Ambrose University, and many undergraduate students who joined as research students or they're part of the undergraduate program here. So I want to thank all of them. Thank you so much for your attention.
Thank you very much, Dr.